Hi, I'm Milan Gandhi. We have developed fleet scheduling analysis tool. This is the executable. We'll click open it. It will take a couple of seconds to activate. This is the application. This is the tool, fleet scheduling analysis tool, and there are two applications: optimal fleet operations and scheduling graph. The first one, the optimal fleet operation application, analyzes the optimal aircraft types using flight operation and characteristics. Let's assume there are two airlines, Airline A and Airline B. Airline A is currently flying a large international network. Airline B is a startup airline. Questions answered here are: what is the total cost by aircraft for the year? And the second question, which aircraft type has the lowest cost per seat per kilometer flown? So let's click this start this application, and this is the parameters which needs to be input. I've just kept it on the developers mode, so we need not input the data. When I click on the new row, automatically the data will be generated, the input data. And when the other part of this application is the new city button, I'll just click that. The other for the data for airline B will be generated, which will be populated. So when I click the new row, the first thing it would be it populate the airline A data, which is currently flying the international network. Based on this data, airline B would be populating this particular data when I click the new city. So first, and then when I generate the button, a report will be there, and we'll see the analysis of that particular report, comparing based on the airline B, which is a startup airline who wants to operate this particular routes. But they have taken, being a startup, they are taking in consideration the data from the airline A, which is already flying the international network. So let's click on new row, and this is the data for airline A. Aircraft types they are flying are this: A320, A330, ATR 72, B73 and B747 and Q400. These are the range, means the distance covered by the particular aircrafts. A320, the distance it can travel is the range, which is called as 5,000 kilometers. A330 is 8,000 kilometers. ATR's distance it can travel is 1,000 kilometers. B737 has got 5,000 kilometers, it can have the range. And B74, that's a big aircraft that covers 10,000 kilometers, and Q400 covers 1,500. So the route they are flying, they would be having should have the range. That route should be having the aircraft which is flying for that route should have the range, what the distance is required to fly from one origin to destination place. The average speed of this particular aircraft is 800, this is 900 average speed, and this is 650 for 800, 900 for B747 and Q400 has got 750 speed. So number of seats available for this aircraft are: A320 has got a capacity of 150. This is A330 has got 250, ATR 72 has got 75 capacity, B37 is 150, this is 350, the B747, the largest aircraft in this particular scenario, and Q400 has got 90 capacity. Now the calculations which by flying this particular aircraft is come to that is calculated cost per flight hours. That is for 1 hour, how much is the cost to fly this particular aircraft for say A320, flying operation cost is 5,000, 7,500. Take it in dollars. 7,000. Then this is 7,500 for A330. For ATR, it's costing per hour is $2,750 per hour. 5,000. B737 has got $5,100. B74 has got 12,000. It's a big aircraft. That's a reason per hour the cost is more. 3,500 is the for Q400. Now the total hours flown by Airline A of all these aircrafts for the year, for 1 year, is so much. Like for A320 it's 14,875. For A330 it is 21,834 hours they flew. This is the maximum they have flown this particular data. Then ATR 72 has got flown 9,536 hours. 11,816 for B737, and B747 flew 11,000 hours, 11,037, and the Q400 flew 9,476. Now this is the data available for the Airline B. So Airline B has got this particular problem needs to be solved for them, which aircraft needs to be assigned to a particular route. So we click on new city, and that is the for Airline B. This data is for Airline B. They want to fly from origin city. This is destination A to B. Okay, and the demand for per day for this particular route is 420 passengers. The distance is 3,000 kilometers, the distance between A city to city B. The same way for B, from B to C, they have got the demand of 450 passengers per day, and the distance is 6,500 kilometers. Now from C to A, the route is they're having a passenger demand of 300, and the distance is 400 kilometers. So, and from A to D, the distance, the origin to destination demand is 300, and distance is 1,000 kilometers. Now the Airline B has to choose which aircraft it should fly, or like from available aircraft types. They have taken the data from Airline A, so they would want to maximize their profits by assigning a aircraft type to a routes. The routes are this one A, and this is B, and the demand and so distances. So which similarly all the routes you can say, and then which aircraft would be they assigning to this particular routes. So this is what the analysis has been done for. So what we'll do is this particular will generate a report, and we'll see the analysis how Airline B would assign an aircraft on their respective routes. Let's which one? Fleet scheduling. We'll open this, and this is where we will save our file, this folder, and we'll say optimal fleet as the file name for its Excel file, and we'll save it there. And we just checked, it must have been generated by now. Yeah, so optimal fleet is generated, and we'll open this to see what sort of an analysis is done for Airline B to operate the route with which aircraft type. So this is the generated report. Now if you look at it, this is the data. We had yellow highlighted fields, the data. We have input on the screens. Here it is, all this data. What we saw here is, yeah, so this is the data which is reflected in this particular Excel file. Now we'll see basically what is calculated. It's all about calculations, and we'll see how it is done. So this data when input, we are taking for airline A at the moment. Aircraft type was given, range, average speed, number of seats, cost per flight hours, and total hours flown. This part. Now the aircraft type here, the same aircraft types are here in the analysis. This is the resultant analysis, and this is the answer, you can say. So total cost per year for A320 was 743 million approximately. It's not approximate, it's a finite figure. And then for A330 it's $1,637,000 for a year, and the same way for ATR the total cost was 262,000 262 million. And for B737 was 602 million, and this was 1 billion for B737, 1,324 million, and for Q400 was $331,000. So this particular total cost came, was calculated based on the total number of hours flown by each aircraft type, A323 of all this aircraft, and cost per flight hour. So this into total flight hours flown into cost per flight hours. So this figures have the total cost for the year has come. Now the other part which is calculated for the airline A is the cost per seat kilometer. Based on this, the airline A would choose which aircraft to fly, basically, because this gives you the real picture of how much it costs for a seat per kilometer. So this is where airline B will be looking at to assign a particular aircraft based on this particular figures. So A330 has got per kilometer cost per seat per kilometer is $0.01. For A330 is 0.33. This is the lowest, I think, and the rest is 0.56 for ATR 72. B737 has got $4.42, and B73 has got 389, and then Q400 has got $0.51. So that is the cost per seat. It is so what basically this is calculated by this calculation is done by total hours flown. This calculation is done by first it has to take total cost divided by number of seats, that is this per aircraft whatever the seats are available, so into total hours flown and average speed. This is the average speed of each aircraft. So based on this this figure of cost per seat per kilometer has been derived. Now this is the part of airline A. Now airline B is using this data to assign a particular aircraft for this particular routes A to BB, BB to CC, and CC to A, and so A to D. So now the calculation for this this calculation has come for the total cost for route of A, BB, BB, CC, and CCA, AAD. This is of airline B. Now they have got this particular figures for total cost for A320, A330, and so on and so forth. So let's look at the cost. What's the total cost for flying a particular route? So the first of all we'll see the total cost of flying A320 for the route AABB. That is this one, this, and this. So this is the route which is flown, which has got a demand of 420 passengers, and which has got the distance of 3000 kilometers. Now which aircraft would they choose? So they have what they have chosen is, here is the answer. For ABB is the optimal aircraft is A330. A330 will be flying this route of A to BB based on the demand and the distance, and what it has got is that it will cost them $500,000 per year to fly this particular route A to ABB, and the cost is total cost is calculated is cost per seat per this has taken to get this figure, cost per seat per kilometer into number of seats, that is of the aircraft types A330 to 320, 330. We'll look at A330, which is assigned here for the AA route. So it has taken this particular number of seats, it has got 250. The demand is 420 per day. So based on that, and then we have the trip distance, that is the this one kilometers to be flown, 3000 kilometers. It can fly 3000 kilometers because it has got a range of 8000 kilometers, so that is applicable. So this is the way the figure of $500,000 per year is come. If you look at all the compared to all the other aircraft types, the total cost, this is the minimum. The A320 costs 562,000, and then this is 573,000, and this is 800,000. So this is the way. See, this is a non-applicable because the distance they cannot fly. Here it is for ATR to which can fly only 1000 kilometers, whereas the required distance to fly is 3000 kilometers. The same way for Q400, which is not applicable because it can fly only 1500 kilometers. Now this is the way this particular aircraft is flown, and number of trips required is 2. So it will go from A to B, and it will come back from B to A. So this is one route is covered, means 2 trips would be needed from A to B and again A to B to cover the demand of 420 passengers. Similarly, we looked BB to CC, this particular route which has got 450 passengers demand per day and has got the distance of 6500 kilometers. So A330 is assigned because it can have the range of 8000. It has got the capacity 250 and the demand is 450, so it can fly twice. The number of trips required is 2. So, and similarly, if you look at CCAA route, and we'll look at the cost, how it is done here from BB to CC. This is not applicable. A320 is not applicable because the distance to be flown is 6,500, whereas the range it can fly is 5,000 kilometers only. So again, this we'll see the cost part of it. The A330 is having 1,833,000, 1 million, and the other one which is applicable is B747, which has got a big range, and it can the seats are available. That's 330, but it is costing 1,073,000. So here also A330 is applicable, and here you can see A330 for the required number of trips is 230, and for the route BBCC. So this one was also calculated. Now we'll look at CCA route, which has got the demand of 300 passengers per day, and the distance to fly this route is 400 kilometers. So here by the calculation it is assigned A320 that can do this particular thing. The range is applicable because only 400 kilometers I think is there. 400 kilometers, it can go for 5,000 range, 150 passengers, whereas the total number of passengers to fly is 300, so they can have 2 trips from CC to AA. So A320, and we'll look at the cost part of it here. CCA, this is costing $50,000. A320 per year, it will cost $50,000 to fly this particular route, and whereas the rest of them are more 6-year A320, rest of the figures are more. So this particular aircraft A320 is assigned to CCA, and it will have number of trips is 2. Now if you look at so this was the lowest for CCA route, $50,000 per year for the short trip, basically for 400 kilometers. From now there is another route A to D, which has got the demand of 300 same per day, and the range is 1,000 kilometers is just to fly the distance. So A320 is been chosen here. It will require 2 trips from AADD to AADD to cover the demand of 300 passengers. It has got a sitting capacity of 150, so 2 flights would fulfill the demand, and the range is also 1,000, so which is applicable here. It can fly 5,000 kilometers, and we'll see at the cost part of it. The total cost per year is the minimum for this particular A320 is $125,000. The rest of them are 166,000, 169,000, 127,000, 133,000, and 186,000. So the lowest cost is this. So this will be the most profitable aircraft, A320, to fly, AA to do DD, and it will have 2 flights to fly for it. So this is the way this analysis is done based on the data from Airline A. The startup Airline B can evaluate the which is the most profitable aircraft to assign for a particular route. So in short, the Airline B can use 4 aircrafts of type A320 and 4 aircrafts of A330. So this is the way they can utilize their resources to maximize the profit. So this is one application about the optimization Now the second application we'll look at is the is the is this this is going to be a second application, and this application will generate a time-space network uh, map, a graph you can say, which is this is the application basically. If you look at from the which needs to be inserted in this particular package, the scheduling graph. So application is there, and this is the UI for that. And what it will do is it will generate this scheduling graph. What it does is this it will generate a graph, time space network graph, which is a problem of fleet assignment. It's a fleet assignment network representation. Basically, what are the problems in fleet assignment is that flight schedule is there. Each flight needs to cover exactly once by one fleet type. Then there is another problem, number of aircrafts by equipment type. Can't assign more aircraft than available for each type. The turn times by fleet at each station. The other restrictions being maintenance, gate, noise, runway, etc. The operating cost, spill and recapture cost, total potential revenue and of flights by fleet type. These are the problems needs to be looked into for the fleet assignment. The objective of this particular thing is application would be cost minimization or profit maximization assignment of aircraft fleet to scheduled flights, and the maintenance required are satisfied. Conservation of flow, that is the balance of aircraft, is achieved, and the number of aircraft used do not exceed the inventory, that is each fleet type. So what we'll do, this is basically application out here. What we'll do, there are these parameters are there. Now, either you can add flights here, like here, and enter the data here, or you can what you can do is what you can do is import a table directly. What we'll do, import a table, and we'll see that's an Excel table. So we'll click on this, and there is we'll go to okay, yeah, I've just kept it here. We'll enter. I've already input the data, so it doesn't take much time. So this is the data input for this application. We'll look at this Excel file which I've opened it here. The data, this is the same thing what is represented here in the UI. This is this thing, but it will be much more clearer if I showcase it in an Excel file. So so we'll look at this data. Yeah, so there are parameters, this aircraft type. There are seats available for this particular aircraft type. The turn time, that is once the aircraft lands, it has to come back, it has to take a turn time to get back to the another flight, to be ready for the other flight. That's the turn time. Then this is the flight numbers, and this is the origin, this is the destination, this is the departure time and arrival time. Now basically we will be generating a report to see how this flights are assigned for this particular route A to B, origin to destination, at what time, departure time and arrival time. The real answer to this particular problem of fleet optimization, fleet scheduling optimization is this, which I have already input. These are the algorithms which needs to be used to generate this result, and that would be in another application. Here we are just going to generate a graph. So the network representation is done, and based on that we'll see so here we can see aircraft 320 has got 144 seats. This is a scheduled design. Basically this is what the airline publishes, the schedule, that flight from origin to destination is there, departure time is there, arrival is there, flight number is there, and this is not applicable turn time, but the seats is not applicable to the aircraft. We for this particular generation of craft we've used this particular data. So we'll have a look here. A330 20 has got the number of passengers is 144. The turn time is 15 minutes. It takes turn time. Its flight number is L1. Origin is A to B, and the departure time is 8:30 a.m. to 10:15 a.m. So it's a 1 hour 45 minutes flight for A320. Then there is a B737 which has got the number of seats available is 108, and 15 minutes for all the turn times, and the L2 is the flight number, origin is C, and destination is B. It has got from 9 a.m. to 10:30 a.m. It is 1.5 hour flight. The next flight which is also there, which is B734, which is 11 to 12:30, 1.5 hours. Then there is another A320 1 hour 45 minutes and 2 hours. 15 to 3, 1 hour flight, and again 1 hour flight from 4:30 to 5:30. So what we'll do, this is we'll come back to this Excel. First we'll generate a graph based on this data which I have input. This is the data which is what we have seen in the Excel, and now we'll generate a report. Now we'll we will name this particular where is the scheduling. We have got the folder is scheduling. Yeah, fleet scheduling. So this is the where we're going to store. We'll name this as a time space. Time space graph it is. So we'll save it in this folder. See this folder is generated, graph is generated successfully. We'll go to this particular time space graph. We'll see, open this graph. It is in PNG file. It's a graph. So yeah, we can see this is a graph generated. This is what we saw, and this is airport A, airport B, and airport C. Right? This is where we have seen. These are the origins and destination: airport A, airport B, airport C, B, and so and so. So this is the way the graph is generated: airport A, airport B, and airport C. Now if you look at it, there is something you can see at this is the timeline. We are from 8 to 18, the number of in a day. These are the schedule in which this particular aircrafts are flying. You can see we'll see the first flight which flies from this Excel side, that is 8:30 to 10:15 p.m. 10:15 a.m. So that flight is represented here, that is from A to B, airport A to airport B. Okay, you can see the timeline here is 9 o'clock here, 10, 11 and so forth. So 8:30 is here, and it is coming at 10:30, I guess. It's 10:15. So if you look at it, it's here 10:15. This is 10 o'clock, so it is representing that 10:15 out here. So this is the L1 flight. Now we'll look at which was the second flight. From 9 a.m. to 10:30 p.m. 10:30 a.m. 1.5 hour flight, L2. That is flight number. So here we'll see L2. L2 is generated, and which is from 9 to 10:30. 9 o'clock. This is 9 o'clock. L2, and this is 10:30. 10 is here. So if you look, it's 10:30. Similarly, we'll see the third flight, L3. This is 11 to 12:30. L3 is here. So this comes here the same way. Okay. So a third flight is here. That is from which time? 11 to 12:30. So if you look here, 11 o'clock and 12:30 is here. So this is the L3 flight. Now we go to see the L4 flight. The next one is L4. Here it is. Okay. It's from 2 to 3:45. That is 1 hour 45 minutes flight. So this is here L4. From the time to what was that? 2 to 2 o'clock. That is 14 hours to 3:45 p.m. So this is the one. Okay, from here, from airport B to airport A, L4. Now the other one is L5 flight from C to A, 2:15 to 3:15. Now C L5 you can see here. From here, this is L5 to here it goes. So this is the fifth flight, flying for 1 hour flight. This is, and it's 2:15 to 3:15. If you look here, 2:15, that 14 hours, then 2:15 to 3:15. So this is one L5. Then L6 is from 4:30 to 5:30, if I am not mistaken. L5 is from 4:30 to 5:30, from A to C. So it's gone again from here, the airport A to airport C. L6 is generated. L6 file is there, and then this is the way the flights are on the network. This is called as a time-space network, where the you can see the these are called as the flight arcs. One is a flight arc. This is also called as a flight arc. 2, 3, this is called as a flight arc. The 4, this is called as a flight arc. 5 is this 5. This is a flight arc. This is 6. This is also flight arc. So there are 6 flight arcs. These are called as nodes, N1, N2, and so on and so forth, are all nodes. There are 12 nodes, N2, N5, N7, N4, then N6, N9, N12. So total number of nodes is, these are the nodes basically. This point is the nodes. And what is the other one is ground arcs. These are the ground arcs. There are 9 ground arcs from here. These are all ground arcs. This is also a ground arc. This is ground arc, and there are total number of is 9 ground arcs. Flight arcs is 6. So total arcs are 25 and the nodes are 12. So this is the way the generation of graph. This is the timeline from 8 a.m. to 18 p.m. We have taken into consideration for this example 9 hours, 9, 10, 11, 12, 14, so and so, and it precisely generated the graph from one point to another, from airport A to airport B and B to C, and so on and so forth. So when we look at this particular assignment of this particular aircraft, we've chosen A320, and from airport A to airport B, and the same A320 is from B to A. So if you look at the representation of that is L1 first and L4, so the same aircraft is used from for this particular origin destination, L1 and L4. So in graph, if you look at it, L1 is this from airport A to B, and from L4 you can see from B to A. So one aircraft is used, A320, from here from airport A to airport B, then it has to wait for till time it gets another flight, and then it flies back to airport A. This is basically done to for the profit maximization of based on the operating cost of particular aircraft, and revenues generated, that is fare, that is based on fares and number of passengers. So in this scenario, this particular aircraft A320 was most profitable to fly this particular route. Now similarly, if you look at it in the Excel file, you will have B73500 assigned for C to B and B to C. So what it does is this is L2 and L3. So we'll look at the flight L2 and L3. This is L2. It goes from here C to B, which is here, C to B, then B to C. So if you see for the airline, this is much more economic, profitable from there to fly L2 from C to B and from B to C. So this is it. This is the way the B737-500 has been used to maximize their profit, and the other one is used is again B37 is being used for this route from C to A and A to C. So we'll see that is L5 and L6. Here we go. L5, this is C to A, and the same way C to A to C, that is L5 and L6. So this flight numbers been flown. So this route was economical and profitable for the airline to assign this particular aircraft types. So this is the way graph has been generated, and then there would be another step which would assign the particular aircrafts. We've already assigned it as such because this is just a generation of graph application. Basically this particular aircraft types are automatically generated based on the algorithms. They can be assigned. So that is another application altogether. So this is the tool we have developed for the airline to take into consideration the fleet operations and want to generate a time-space network. Thanks for watching it.